Hi and welcome back. We're going to look at section 2.2 today, which is the derivative of a function. So picking up from where we left off in section 2.1, most of those we did the derivative, finding the derivative of a function at a specific point. We did do a few of them that were the function ones, but this section is dedicated strictly to finding the derivative of a function. So that brings us to the definition of derivative of a function, which is the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, remember that's the one you only have the one choice when you're finding the derivative of a function. So Dr. Taylor did 3 with you, a polynomial, a radical, and then a rational function. So I'm going to do the same thing. We're going to work on one of each. Again, this is, really all about practice, and the more you do it, the easier these steps get because they're very similar for each type of problem. And for your test coming up to show the derivative using the definition, you will only be given one of these 3 types of problems, okay? The polynomial function, which he did number 1 for you, a radical function, or a rational function. I won't ask you to do any other types as far as doing it the long way using this definition. So we're going to go through and do number 4, 5, and 6, which is again just doing one of these with you to make sure. So hopefully it gets easier as you go. Okay, it's the same formula each time you do it. So for number 4, it's a polynomial. So again, we're looking to find the derivative f prime of x, which is the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so remember, doing your algebra, all this first part means is everywhere there's an x in the problem, you're going to substitute it in with x plus h. So your first step, limit as h goes to 0. So we have x plus h squared plus 3 times x plus h minus 2. So everywhere there was an x there, I substituted in the x plus h. So that's the first part. Okay, that is just f of x plus h. I always put the minus when I'm doing polynomials, and then I put the function, which is the original function, in parentheses. Now you don't have to do that. You can go ahead and change the signs right now, but a lot of you just put minus and write it and don't put it in parentheses, and then you get this wrong because you forget to change the signs. So just make sure you remember to do that. Okay? All right, so now it's just about simplifying. So we have the limit as h goes to 0. I'm going to go ahead and square that, which is x squared plus 2xh plus h squared. Remember that you have to FOIL, right? That's not just x squared plus h squared. You have to do x plus h times x plus h, so you got to FOIL that. All right, I'm going to distribute the 3 through here, so that's plus 3x plus 3h minus 2. And then I'm going to go ahead and distribute that minus sign. So minus x squared minus 3x plus 2. All over h. All right, so I'm going to simplify, cancel. Some things will cancel. Otherwise, I'm just going to simplify this. So let's look. We have x squared minus x squared. So those are going to go away. I have a 2xh, and I don't have any other term that has xh in it, so that's it. I have h squared. I have no other h squared term. I have a positive 3x and a negative 3x. That's going to go away. I have a positive 3h, and then a negative 2 and a positive 2. So that's all I'm left with. Then remember, we're going to now cancel the h in the denominator with each term up here. Make sure you do that. Don't make the mistake of just canceling it once and then being done. Remember, h has to divide into everything in the numerator. Okay? So if I divide 2xh by h, I have 2x. Divide h squared by h, you have h. And divide 3h by h, you have 3. Now we're going to do our direct substitution. So we're going to let h go to 0. So 2x plus 0 plus 3. So the derivative function, 2x plus 3. Okay, so down here I'm going to write that f prime of x, the derivative, is 2x plus 3. Again, that's what I need to see on this test if I ask you to find the derivative. No shortcuts. For those of you that know the shortcuts, we don't do the shortcuts until after test 1. So please practice this, okay? I will take off points if you have the answer but not the work on these. So you need to be able to do these. All right, so moving on to number 5, that's the rational function. Okay, so we're going to find the derivative. So in this case, it'll be k prime of x. Okay, so that's the limit. Sorry if you hear that noise. My dog is drinking water. All right, so we're going to do the limit of f of x plus h minus f of x over h. All right. So looking at this problem, again, all this notation means is to replace any x in the problem with x plus h, okay? So we're going to have the limit as h goes to 0, and then we got 2 over x plus h minus the function, which is just 2 over x all over h, okay? Now, when I do rational functions, instead of doing this divided by h, because you get fractions and fractions. So, over here I didn't do it so much because we just had a fraction. But what I like to do with rational functions is pull this out front and just write 1 over h, just so that it kind of gets rid of it. You don't have to do that, but it just kind of helps. So instead of all of that mess, now I can just deal with the fraction. This part in here and get my common denominator. Okay, so multiplying by 1 over h, that's the same thing as dividing by h. So it kind of just helps clean this up a little bit. If you want to leave it all over h, that's fine. So now I'm going to get a common denominator. So that 1 over h is kind of out of the way now. All right, so remember, when you have fractions like this, I just cross multiply. So to get your common denominator, you do this, you always start in the top left, this times this, whatever that sign is, and then you do this times this. That's your numerator. And then in the bottom, you just multiply these together. Okay, so that's what I'm getting ready to do. So I'm going to do 2 times x, which is 2x, minus, and then I'm going to do 2 times x plus h. I'll multiply it out in a minute, over, and then I'm going to do this times this. So I'm just going to write it x times x plus h. That's how quickest way to get your common denominator. So now we need to clean this up a little bit. So the limit as h goes to 0. Don't forget about the 1 over h. All right, so I'm going to distribute that negative 2 through there. So 2x minus 2x minus 2h over, and I'm just going to leave the bottom alone. You can multiply it out if you want to. You don't have to. It'll all work out the same. Okay, so now I have the limit as h goes to 0, 1 over h. All right, so now I've got to clean the top up, so the 2x's are going to cancel out. Be careful, you still have that minus in front of the 2h over x times x plus h. Okay? All right, so now we're going to simplify. So now this h will cancel with the one in the top. So now I have the limit as h goes to 0 of negative 2 over x times x plus h. All right, so I've simplified it. That's where I'm at. So now I can do this direct substitution. I'm going to let h go to 0. Okay, so that will give me negative 2 over x times x plus 0. Be careful on this one. So that gives me negative 2 over x times x, right? X plus 0 is x, so x times x is x squared. So there's your derivative. And so again, I'm going to write k prime of x. The derivative over here is negative 2 over x squared. Okay, so there's your derivative of the function k. All right, last one we're going to do is the radical. So number 6, square root of 2x plus 1. Okay. So this time we're doing the derivative g prime. So that will be the limit as h goes to 0. I'll write it out again, f of x plus h minus f of x all over h. Okay? All right, so on this one, we're going to substitute in x plus h for this x right here. So that is the square root of 2 times x plus h plus 1. Okay, so that's the f of x plus h. Now we're going to subtract the original function, 2x plus 1, square root of it, all over h. Okay, now you can distribute the 2 through there right now. I mean, it's totally up to you how you want to do that. I don't know if most of you will or will not, so I'm going to go ahead and I don't know which way is better. I don't think it really matters. I'm trying to think of how most of you guys might do that. So let me go ahead and multiply that out, just so we have individual terms. So 2x plus 2h plus 1 minus the square root of 2x plus 1 over h. Okay. All right, so remember that we need the conjugate anytime you have radicals. So the conjugate of the numerator will be the square root of 2x plus 2h plus 1. Remember, the only thing that changes in the conjugate is the sign in the middle of the two terms. So plus square root of 2x plus 1. And whatever you do to the top, you're going to do to the bottom. So same thing down here. All right, now remember the rules. Why conjugates work out so nice. They look awful, but they really make life easy. So when you FOIL the top, you're just going to do the first and the last. And the bottom, remember the part that's not the conjugate, you just leave it. You don't have to do anything to that. Okay? So we're going to multiply the first two terms, and when you multiply a radical by itself, it gets rid of the radical. Now be careful. When you do the last, you've got a positive times a negative, so you're going to get minus 2x plus 1. So we're going to have to change those signs. That's probably the biggest mistake I see in this type of problem. So you have a positive times a negative, which is negative. But then you have a binomial in here, so you have to make sure you take the opposite of both of those. Okay, so we'll do that in the next step. So in the bottom, we have the h, and then times that bottom. Just leave it the way it is. Okay. All right, so this we're going to distribute. So this is going to become a negative 2x and a minus 1, right? So be careful with that. Now you could do that all at that first step, but I'm just trying to, for those of you that need to see all that. So minus 2x minus 1 over that denominator, h times square root. A lot of writing, but not a lot of work. Okay. So now we're here. So we're going to simplify the numerator. So we have the 2x canceling out. We have the 1's canceling out. So now you are just left with the limit as h goes to 0 of 2h in the top over h times that conjugate. Okay. All right, so now you'll see the h's will cancel. So we're finally down to the part where we're going to be able to do our direct substitution. So we have 2 over the square root 2x plus 2h plus 1 plus square root of 2x plus 1. All right, so now we're ready to do direct substitution. So we're going to let h approach 0. So be careful with this. All right, so in the first radical we have 2x plus 2 times 0 plus 1. Plus, and in here we have the square root of 2x plus 1, right? All right, so 2 times 0 is 0, so we end up with 2 over the square root of 2x plus 1 plus the square root of 2x plus 1. Right? So that's what we're down to. So one square root of 2x plus 1 plus another. Remember, when you have like terms, that gives you two of those. So that equals 2 over 2 square roots of 2x plus 1. And that's how you add like radicals. Now you have 2's in the top and the bottom. That will cancel out. So you're left with 1 over the square root of 2x plus 1. So that is your derivative. Okay, so the derivative g prime of x is equal to 1 over the square root of 2x plus 1. So there's your derivative. Now, I know that's a lot of steps. I understand that. And I know a lot of you are thinking, if you know those shortcuts, why? Again, when you first started, you all did this. We have to do this by the definition. This gets you kind of a little more practice on your algebra skills, but also it is the legitimate way to find these derivatives right now, because in this class we haven't learned that. Now, you know, you can use your shortcuts to check the answers, but I have to see these steps, okay? All of you, especially those of you that don't like showing your work. You only have to do it for 1 or 2 problems on your test, so it's not going to kill you, but you have to do this to get the points. Otherwise, those points are coming off of your test, okay? So I cannot stress that enough for you. So please, please, please make sure you do those. All right. Now, number 7 came out of the textbook. Not that you have to have the textbook, but it came out of the textbook. And in the textbook, there were some grid lines in here. Because what you're asked to do in number 7 is to estimate the derivatives of each of these points A through F, right? The derivative of A, the derivative of B, but it says to estimate. So I'm just going to go through real quick and plug in or draw some vertical and horizontal lines, kind of like, you know, it's on graph paper, okay? So I'm just going to lightly draw these in. I'm going to try. Okay, so there's some horizontal lines as best I could do. Okay, and then we're going to draw in some vertical lines. So I think if we do them all here, okay. All right, so again, not the best, but we're estimating, okay? All right, so if you look at these points now, we're supposed to find the derivative at point A. Okay, so remember what the derivative is. It's the slope of the tangent line at that point. So if I draw a tangent line through here, that's what I'm looking for. Okay, what is the slope of that? So all we're going to do is estimate. So again, we're looking at points that are falling on this grid. So I know this slope is going to be negative, and then I would just look at the 2 points closest to it, and I would go down 1 over 1. So I would estimate that the slope right there at point A would be -1. Okay? Now if I go to point B and look at the tangent line, that's a horizontal line, and I know the slope of any horizontal line is 0. So the slope of point B would be, or the derivative at point B would be 0. All right, let's look at C. Okay, here's point C. So I'm just looking at that tangent line as I go through point C. So, you know, here's a point, the next closest point that kind of goes through a grid line, I would say, is up here. So I might say the slope is that I went up 1, 2, 3, and I went over 1. Right? So I would say the slope or the derivative at point C is around 3. Right? Up 1, 2, 3, over 1. So that's the first point that I see that might be on the grid line. So just extend your lines until you're happy with that. If you said 2, that's fine, okay, depending on how you drew your lines. All right, at point D, what's the derivative at point D? Well, the tangent line at point D is, again, another horizontal line. So the derivative has to be 0. Okay, E. Point E also has a horizontal tangent line, right? So that also would be, the derivative would be 0. And lastly, I'm going to look at point F. So if I look at the tangent line at point F, extend it a little bit. Here's a point on the grid, and there's a point on the grid, right? So I would say I went up 1, 2, 3 again over 1. So I would estimate the slope at point F, the derivative at point F, to be 3. Now, again, I'm just estimating. Okay, if you put 2, even if you put 1, I'd be okay with that. More importantly is that I know that the graph is the horizontal points, the points at your max and min, those are definitely horizontal tangent lines, so those have to be 0. The other ones, you know, you can kind of fudge those numbers a little bit. All right, so take a look at this. Let's look at the derivative then. The derivative at A, so I'm going to write all these points, A, B, C, D, E, F. A, B, C, D, E, and F, because we're going to do this as we go through this course. So what did we get the derivative of A to be? The derivative of A was at -1. The derivative of B was at 0. The derivative of C was up at 3. The derivative at D was 0. E was 0. And F was back up here at 3, right? So if I were to graph those points, just to kind of look at them, it would go like this. It would come back down and maybe up like that, right? I don't know what's going on each side of that, but typically that's kind of what would happen. So this is the derivative function, because remember, the derivative is a function. So if we piece together all the derivative points, we get another function, okay? So that's kind of how that would work. All right, so that's what we're kind of getting to eventually. Not yet in this section, but we will. All right, underneath that, then we talk about notation. Now I know Dr. Taylor went through these with you, but again, just to remind you, you know, there's lots of ways to write derivative. Most of the things that we do in here, you'll either see f prime of x, or whatever the function name is, like g prime of x. Okay, that means it's a derivative function. You'll have the Leibniz direct function notation, which is the dy dx. And again, I know he went through that function talking about, you know, the change in y over the change in x. That's where this came from. And so delta, meaning the d. So this is just another way to tell you you're finding the derivative. And then you have y prime, okay? So y prime is just another way to say f of x, right? So those are the three main ones you guys are going to see today. He also talked to you about second derivatives and kind of getting bigger. We'll do those as we go along, okay? So just know there's different notations for derivatives. All right, then we talk about these definitions. Dr. Taylor went through this with you. So just remember, f of x is differentiable at a point A if and only if the derivative at that point exists, okay? So if there's no derivative at a point, then the function is not differentiable at that point. And then more importantly, a function is differentiable on the entire interval from A to B if it's differentiable from every point within that interval. So again, you have to be able to find all the derivatives at points on an interval for it to be differentiable. So he went through, these were on the video, talking about corner or cusps, right? So right here at 0, the derivative of 0 does not exist because, again, there's no derivative there because we can't find the slope there because the slope of this line is negative, the slope of this line is positive. So where they meet, that's a corner or a cusp. So the derivative is not going to be differentiable at that point. Now it's differentiable all around here and it's differentiable here, but not at 0. Here's another place where it's a cusp, right? It changes. So if that was A, then we'd say the derivative of A does not exist as well. Not differentiable at those points. Okay, we can't find the slope from two different lines. I don't know which line to use, or curve, so I can't find the derivative. All right, Any point where there's a discontinuity, again, the derivative would not exist. So f prime of a would not exist here, because again, I have two different things. Am I supposed to use the derivative of this point and find that tangent line, or the derivative of this tangent line? So if there's a break, discontinuity, there's not going to be a derivative. Asymptotes, okay? When you have an asymptote at A, you definitely cannot find the derivative there. So that's an asymptote. So discontinuities. So this one was jump, and this one was an asymptote, but same thing. Can't find it. And then also, we did, on the last page, we did horizontal tangent lines. When you have a horizontal line, the derivative, the slope is always 0. But you guys remember any vertical line, that there is no slope, right? Or it's undefined. So anytime you have a vertical tangent line, you cannot find the derivative. So those would not be, there would be no derivative at vertical tangent lines as well. They do not exist. Okay, so 3 different kinds of place: vertical tangent lines, points of discontinuity, and then we have our corners and cups. So those are pretty much the only 3 types of places you're not going to see tangents, derivatives of tangent lines existing. Okay, all right. Last page of these notes. So we're going to look at number 8. Now, this came from WebWorks and they're color coded. So if you've got this printed out, again, before you got your notes, but hopefully you have your notes, you'll see the colors. So function A is a linear function. Function B, if it looks like it, is a quadratic, right? It looks like a U, part of a U. And then C, if you look at it, it kind of has a couple of curves in it. So this is a polynomial function, okay? And I'm going to look back at what we did in our example for number 4, I think it was, because this is just about patterns. So remember in number 4, we had the function x squared plus 3x minus 2, and then we went and found the derivative of that function, which was 2x plus 3. So that's what I want us to look at for this function, is just kind of looking at the pattern, because we will need this in future sections. So as we find a derivative, notice that the power or the degree goes down by 1. Okay, when you're talking about polynomials, and that this is about polynomial functions. So what we want to look at is looking at the degrees of a polynomial so that we can kind of figure this out. So I'm going to start with the red curve, curve B. I know that this function, the highest power was x squared, okay, because it's a parabola. If you look at the linear function, graph A, I know that the highest power for that would be x, right? That's a straight line. And then this polynomial function right here has a couple of curves in it. So it could be higher, but I'm going to say that it's x cubed right here. So this has to be the function, and then x squared would be its derivative because it's 1 degree less. And then line A would be the derivative of x squared, or the second derivative. Okay, so as we go down in powers, that's how we can kind of tell derivatives. So the graph of the function has to be function C. Okay, that was the x cubed. The graph of the function's first derivative, that would be 1 power less, so that would be b, x squared. And then the graph of the function's second derivative would go down another degree, so that would have to be a, which would be the highest power would be x to the first. Okay, and that's always true for derivatives. So we'll learn that when we get to the shortcuts in section 2-3. But just from what we've done already, always your derivative is going to be 1 degree less than the function before it. Okay, so that's what they wanted you to kind of see on that one. All right, number 9. I just want to go over this with you because this is a factoring problem where you need to know how to factor a cubic function. But let's remember that, and this is not from this section, this is back on limits, so these are just some review problems. So for number 9, if we plugged in 1 1 cubed is 1, and 1 minus 1 is 0. And in the bottom, 1 squared is 1, minus 1 is 0. So we get that indeterminate form. So that means we can work that out. So I just want to do this with you. The limit as x goes to 1. Do you remember how to factor a cubic function? Okay, the bottom is the difference of squares. I know that factors x plus 1, x minus 1. But do you remember how to factor a cubic function? Okay, so cubic functions factor. You take the cube root of each. So what is the cube root of x cubed? What times what times what gives you that? You take the cube root of 1, which is 1, and you take the sign in the middle, okay? Then you get a polynomial over here. So the other factor, if you remember, is you square the first term, which is x squared. You always change the sign. And in the middle term, you just multiply these two numbers together. So 1 times x is x. And then the last term, you square. So -1 times -1 is a +1. Okay, so that's how you factor a cubic. Okay, I'm going to put another cubic over here real quick. Let's say x cubed plus 8. So if I asked you to factor that, you would take the cube root of both terms. So the cube root of x cubed is x, and the cube root of 8 is 2. You always keep the sign in the middle. And then the trinomial at the end, it always follows the same pattern. You square the first term, you change the sign, you multiply those two numbers together to get 2x, and then you square the last term, which is 4. So that's how I would factor that. Okay, so I did 2 of them real quick for you, but that's the rules for factoring. All right, so now I can simplify, go back to this problem. The x minus 1s will cancel, and so I'm left with x squared plus x plus 1 over x plus 1. And now I would do direct substitution again. I'm going to put in 1 here, so 1 squared plus 1 plus 1 over 1 plus 1. So I end up with 3 over 2. So there would be my limit. Okay, so you guys don't factor cubic problems a lot, but you did learn how to factor those, so just wanted to go over that with you. I think that's coming out of WebWorks. And then please, on number 10, there's a typo here. We left off a part of the problem. It should have a -6 right here. That's the actual problem. And this is one of your notes check problems. So please make sure you make the correction. So this was just a typo. We left off -6. So this is the actual problem that you should be working for number 10. Okay, so it's the square root of x plus 36 and then -6 on the end all over x squared. The limit as x approaches 0. So if you plug in 0, okay, you get 0 squared plus 36, so that's 36. Square root of 36 is 6. 6 minus 6 is 0, and in the bottom you get 0. So again, this is of the form 0 over 0. It's an indeterminate form. It would not be an indeterminate form if that was not there. So please make sure you do that. Okay, because again, this is I think the last problem on your notes check. So we're going to use the, well, let me write it as another step. So we're going to do the conjugate, right? So we're going to do the square root of x squared plus 36 minus 6 over x. We're going to multiply by the conjugate, which is the square root of x squared plus 36 plus 6. Top and bottom. Okay? So we've done these before, so we're going to go through, multiply the top by foiling first and last only, and then don't change the bottom. Leave that the way it is. All right, so we're going to multiply the square root of x squared plus 36 times itself. That gets rid of the radical. And then we're going to multiply -6 times 6, which is -36. And the bottom we're going to leave. You don't have to multiply it out. Okay. All right, so we'll see in the top, we have 36 minus 36, so that's going to go away. So now we have the limit as x approaches 0 of x squared in the top, and then over x times this in the bottom. Okay. Lost an x squared, so hopefully you guys saw that. And just noticed I wrote x in the bottom. It should be x squared. Sorry about that. So all those should be x squares in the bottom. So now you'll have the x squares that cancel out. Found my problem. Okay. So we have x squareds canceled, so you're left with 1 in the top, and then the x squared, square root of that in the bottom, plus 6. Okay, so make sure you fix that x squares. All right, so since the x squares cancel out, this is what I'm left with, and now I'm going to do direct substitution again. So we have 1 in the top. In the bottom, we're going to do 0 squared plus 36, and then plus 6. So that gives me 1 over the square root of 36 plus 6. Square root of 36 is 6. So we end up with 6 plus 6, which is 1/12. So your answer for number 10 should be 1/12. Okay? All right, and again, 8, 9, and 10, I believe, are all coming from WebWorks. So a lot of times in WebWorks, they'll put some review problems in there for you to do. So that's what 9 and 10 are. Those are just limit problems using the direct substitution, finding the indeterminate form, so doing your simplifying. Okay, so good practice before your tests coming up. All right, so that does it for section 2.2. You've got those answers now. So keep working on your homework and let me know if you have any questions.